In today's session, we are going to take a look at problems related to applications of trigonometry, more so problems related to heights and distances. Let us take a look at the first question. As observed from the top of a lighthouse 100 meters above the sea level, the angle of depression of a ship changes from 30 degrees to 45 degrees. Determine the distance traveled by the ship. So let us draw a neat diagram for this now. Let's assume that this is the sea level and there is a lighthouse. So the lighthouse is going to be vertical, thereby making a 90 degree with the sea level. And the distance, the height of this particular lighthouse is 100 meters. So if you're standing on this particular lighthouse, your normal line of sight is going to be parallel to the sea level. This is your normal line of sight. So let me mark that. This is the normal line of sight. And there is a ship. The angle of depression of the ship initially was 30 degrees. So I know that the angle of depression is the angle made by the depressed line of sight with the normal line of sight. So this particular angle is the angle of depression and this is found to be 30 degrees. So this is the angle of depression, and later on the angle of depression changes to 45 degrees. That means the ship is getting closer to the lighthouse. That is why the angle of depression is increasing, right? So this particular angle is therefore 45 degrees. Now we have to determine. So A is the initial position of the ship. Let us label it. A is the initial position of the ship. B is the final position of the ship. This is the top of the ship, top of the lighthouse, and this is the bottom of the lighthouse. So TS is the lighthouse, and A was the initial position of the ship, B was the final position of the ship. We have to determine the distance traveled by ship. So distance traveled by ship basically is going to be the length AB, and this is the distance traveled by the ship. So now to solve this particular problem, the first thing that I'm going to do is I'm going to convert this angle of inclination problem into an angle of, or rather an angle of depression problem into an angle of elevation problem. So if you think about it, the normal line of sight and the sea level are parallel to each other. Therefore, by alternate interior angles, I can mark this particular angle as 30 degrees and I can mark this particular angle as 45 degrees. This is according to alternate interior angles. So if you notice, these two are the alternate interior angles. Therefore, these are 30 degree each. And then I have a 45 degree angle. So these two are the alternate interior angles. Therefore, angle A is 30 and angle B is 45. Now, if I wish to find the length AB, I am first going to use the triangle TSB. So I will use the triangle TSB to find the length of SB. With respect to the 45 degree angle, I know the opposite side. I want to find the adjacent side. So I can say in triangle TSB, I can say tan 45. Tan 45 degree is equal to opposite side. Opposite side is 100 divided by the adjacent side. The adjacent side equals SB. And tan 45 is 1. So 1 is equal to 100 upon SB, which implies SB is equal to 100 meters. So this particular length is therefore 100 meters. And now I can consider the triangle with 30 degree. So the triangle that has 30 degrees is this entire triangle, that is triangle TAS. So I am going to say in triangle TAS. Now again, with respect to 30 degree, opposite side is 100 meters, the adjacent side is not known. So I will use tan 30. Tan 30 is going to be the opposite side, which is 100 meters, divided by the adjacent side, which is AS. I know that tan 30 is 1 over root 3. So 1 over root 3 is 100 by AS, which implies AS is 100 root 3. And I can definitely calculate the value of AS. So 100 root 3 means this is going to be 100 multiplied by 1.732, and that is going to be 173.2 meters. So this complete length is 173.2 meters. So this is 173.2 meters. And therefore, the distance traveled by the ship is going to be equal to, the whole distance is 173.2 minus 100, and that is basically going to be 73.2 meters. So this is the distance traveled by the ship. Just think about the beauty of this particular topic. You were standing on a lighthouse, on the top of the lighthouse. You have a ship which is coming towards you. You do not know the speed at which the ship is moving. You only are measuring the angles of depression at two particular instances. Okay. And once you measure these angle of depressions, you are able to calculate the distance traveled by this particular ship. That means sitting remotely, you are able to understand the parameters of motion of an object which is far off from you. That is the advantage of trigonometry. Of course, you know the height of the lighthouse, which is why you were able to determine this. So, pausing for a minute before I move on to the next one. Take a look at the word problem, the diagram, and of course the word. Moving on to the next question. Let's take a look at the following question. From a window 15 meters high above the ground, the angles of elevation and depression of the top and the foot of another house on the opposite side of the street are 30 degree and 45 degree respectively. Show that the height of the opposite house is 23.66 meters. So let's consider that this is the street. So imagine that the street is into the screen. Okay, right now imagine that the street is actually within the, it is entering into the screen. So A and B are the end points of the street, and the street, and there is one house whose window is 15 meters above the ground level. So this is the window. So X is the window which is 15 meters above the ground, that is given to us. The angle of elevation of the top of the other house is 30 degrees, right? That means to view the top of the opposite house, so if you are at the window, the horizontal line is your normal line of sight. This is the normal line of sight, right? And this normal line of sight is parallel to the ground. Now, to look at the other house, you have to raise your eyesight. That means from this particular point, if you want to see the other house, there is an angle of elevation which is experienced, and therefore I can say that the other house is over here. So BC is the other house, C is the top of the other house. C is the top of the other house which is situated on the opposite side of the street, and B is the bottom of the house situated on the other side of the street. Now to look at the top of the house, you experience an angle of elevation, and the angle of elevation is found to be 30 degrees. Therefore, I would apply a 30 degree angle over here. So again, this is the normal line of sight. If you want to take a look at the top of the house situated on the opposite street, you experience an angle of elevation, which means that the other house is taller than the window, and the angle of depression. So let us continue reading. The angle of depression of the foot of the house is found to be 45 degrees. That means from this particular point, if you want to take a look at the bottom of the other house, the angle of depression, that is this particular angle, is basically 45 degrees, right? This is the angle of depression. So this is the angle of depression. Therefore, now we have to show that the height of this house. So height of the house basically means the complete length BC. BC is the height of the house. We have to see that the height of the house, we have to show that the height of the house is 23.66 meters. So I will pause before I do the working. Take a look at the word problem and the diagram, and then it is going to be quite easy to solve this question. Okay, so now let us solve this question. I know that if XA is 15 meters, XDBA is a rectangle. So XDBA is a rectangle. And because it is a rectangle, I can therefore say that BD should be equal to XA, which means that this length is also 15 meters. So I know that BD is 15 meters. And now I can consider the triangle XBD. So I can consider the triangle XBD, and I can find the length of XD. So in triangle XBD, I can say tan 45 degrees. Tan 45 degrees is equal to the opposite side, which is BD, divided by the adjacent side, which is XD. Which means that tan 45 is 1 is equal to BD is 15 divided by XD, and this implies the length XD is 15 meters. So this particular length is 15 meters. And now I should find CD because I know XD. Now I can focus on the triangle XCD. I can focus on this triangle, and using this I can find the length of CD. So I can say in triangle XCD, I can say tan 30 because tan gives the opposite side upon the adjacent side. So tan 30 is going to be CD upon 15. Now tan 30 is 1 by root 3, which is equal to CD upon 15, which implies CD is equal to 15 upon root 3. And that is equal to 5 root 3. So if you simplify, if you multiply by root 3 and divide by root 3, you are going to get 5 root 3, which means that the length CD is 5 multiplied by root 3, which is 1.732, and that is 8.66 meters. Therefore, the length of CD is 8.66 meters. This is the length of CD. And now if I want to find the total height of the house, so total height of the house is going to be 8.66 plus 15, and that is going to be 23.66 meters, and hence prove that the total height of the opposite house is 23.66 meters. Again, think about it. You are standing on the top of the window or in the window, in your house, and just by finding out the angle of elevation and depression of the opposite house, you are able to determine the height of the house. Of course, you need to know the height of your own window before you can find out. So this is the strength of the application of trigonometry. Pausing for a minute again. Moving on to the next one. So let's consider the following question. The angle of elevation of a jet plane from a point A on the ground is 30 degrees. Okay, as I read this sentence, let me make a figure. This is the point A. This point is on the ground. The angle of elevation of the jet plane, so let's imagine that the jet plane is here. The angle of elevation, that is this particular angle, is 30 degrees. So let us shade this particular angle, and of course it's given that after a flight of 30 seconds, the angle of elevation changes to 60 degrees. If the jet plane is flying at a constant height of 3600 root 3 meters, so the jet is flying at a constant height of 3600 root 3 meters. So this is 3600 root 3 meters. And now after a flight of 30 seconds, the angle of elevation changes to 60 degrees. That means now again we have to think whether is the plane going further off or is it approaching the observer. Now if the angle of elevation is increasing, if the plane was moving away from you, so think about it, if the plane is moving away from you, the angle of elevation would decrease, right? So assume that the plane is right over here, and if it is moving away from you, you will notice that the angle of elevation is decreasing. Whereas if the plane moves towards you, you will notice that the angle of elevation is increasing. That means the plane is moving towards left, and now the angle of elevation, the whole angle, is now 60 degrees. Of course, the plane is flying at a constant altitude, so the altitude does not change. That means the height of the plane, even at this particular point, is 3600 root 3 meters. So the height of the plane at this point is 3600 root 3 meters. So this is 3600 root 3. So this is the point B, this is point C, this is point D, and this is point E. I now want to find the speed of the plane. Of course, the speed of the plane can be found out as distance traveled over time. The time is given to me after a flight of 30 seconds. That means the time is 30 seconds. Now we need to find the distance. Of course, the distance covered in this case is the length ED. And because EDCB is a rectangle, I can say that the length covered by the plane is equal to BC. So the distance traveled by the plane, distance covered by the plane, is equal to ED, and which is equal to BC basically. So now I need to find the length BC. So first what I'm going to do is I am going to take the triangle. So let's take the triangle ADC. And let us find the complete length AC. So in triangle ACD, I can say that tan 30 degrees tan 30 is given by the opposite side, that is 3600 root 3 divided by the adjacent length, which is AC, and therefore 1 by root 3 is 3600 root 3 divided by AC, and cross multiplying AC becomes 3600 root 3 multiplied by root 3, which is basically 10,800 meters. Therefore, this complete length is 10,800 meters. Let's mark that. And now I can find the length of AB using the given triangle. So now I can consider the triangle ABE. So let's consider the triangle ABE. So in triangle ABE, I can say that in triangle ABE, of course the angle is 60 degrees and EB is equal to 3600 root 3. So again using tan 60, I can say that tan 60 is 3600 root 3 divided by the adjacent length AB, which means root 3 is equal to 3600 root 3 divided by AB, and therefore this implies AB is equal to 3600 meters, right? Therefore this particular length is 3600 meters, and therefore the distance covered by the aeroplane, the distance covered is 10,800 minus 3,600, which is equal to 7,200 meters. This is the distance covered by the aeroplane, and therefore the speed is going to be 7,200 meters divided by the total time taken for flight is 30 seconds, and this is going to be 240 meters per second. Of course, I can convert it into kilometers per hour. So for converting it into kilometers per hour, I'll multiply by 8 conversion factor, which is 18 upon 5. And now if I evaluate this, 240 by 5 is 48, and this is going to be 864 kilometers per hour. Therefore, the speed of the aeroplane is 864 kilometers per hour. So let me pause for a minute while you take a look at the word problem, the diagram, and of course the solution. Moving on to the next question. Let's consider the following question. There is a small island in the middle of a 100-meter wide river. So let this be the 100-meter wide river. Again, imagine that the river is flowing into the stream right now, and a tall tree, and there is an island somewhere here, and a tall tree stands on this island. So this is the tall tree that stands on the island. Of course, this is 90, so let this be CD. So CD is the tree which is standing on this island. The width of this particular river is 100 meters. So the total length AB is 100 meters. And now it is seen that P and Q are points directly opposite to each other on the two banks in line with the tree. So instead of A and B, they have told us that the points are P and Q. these are the 2 points on the opposite banks in line with the tree. The angle of elevation of the top of the tree from P is 30 degrees and from Q is 45 degrees. So it's given that the angle of elevation here is 30 degrees, and when observed from Q, the angle of elevation is 45 degrees. Now we have to find the height of this particular tree. So over here we do not know the length of PD and we do not know the length of PQ also. So what I'm going to do is I'm going to assign a variable x to DQ. So if DQ is x, then the length PD is going to be 100 minus x, because the total length PQ is 100, of which DQ is x, and therefore PD is going to be 100 minus x. So again here we have two variables, h is the height of the tree and x is the distance of the island from one point. So now again I need to build two equations for two variables. So let me first pick the triangle CDQ. Let me pick this particular triangle. So in triangle CDQ, I can say that tan 45 degrees is going to be h upon x, and tan 45 is 1, which implies h equals x, and this is my first equation. So let's mark this as our first equation. The other triangle that can help me is triangle PCD. So let us take the other triangle as well. So in this particular triangle, I can again use a trigonometric ratio which joins the opposite with the adjacent. So I can say tan 30 is therefore equal to h upon 100 minus x, and tan 30 is 1 upon root 3, and that equals h upon 100 minus x. This is my second equation now. Okay, so what am I interested in this particular question? I am interested in finding the height of the tree. I do not care about the value of x because they didn't ask me. Therefore, I am going to substitute. So let us substitute x as h from the first equation, and let's substitute this in the second equation, in equation 2. Therefore, 1 by root 3 is equal to h upon 100 minus h. Cross multiplying 100 minus h is equal to root 3 times h. Therefore, 100 is equal to root 3h plus h. Therefore, 100 is equal to h bracket root 3 plus 1. And h is therefore 100 upon root 3 plus 1. Multiplying the numerator and denominator by root 3 minus 1. So we have root 3 minus 1. And therefore we get h is equal to 100 times root 3 minus 1 divided by root 3 plus 1 into root 3 minus 1 is a plus b, a minus b, which is equal to 2. Root 3 square minus 1 square. So let me just show that here. Root 3 plus 1 multiplied by root 3 minus 1 is basically root 3 square minus 1 square, which is 3 minus 1, that equals 2. And 100 upon 2 is 50, so this is going to be 50 times root 3 minus 1. And now I can substitute root 3 as 1.732. So this now becomes 50 times 1.732 minus 1, which is 50 times 0.732, which is 5 times 7.32, and that is going to be 36.6 meters. Therefore, the height of the tree is 36.6 meters. This is how I use trigonometry to calculate the height of this tree. Pausing for a minute while you take a look at all the components of this problem, the word problem, the diagram, as well as the working. Moving on to the next one. The angles of elevation of the top of a tower from 2 points at a distance of 4 meters and 9 meters from the base of the tower and in the same straight line with it are complementary. Prove that the height of the tower is 6 meters. So in this case, it's given that there is a tower. And there are 2 points in line with it. So there are 2 points A and B which are in the same straight line with it. So let this point be A and let this particular point be B. And this is 90 degrees. This is the tower. So let's name it as TR. This is the top of the tower and this is the bottom of the tower. The angle of elevation of the top of the tower from these 2 points. So angle of elevation is found to be complementary. Complementary means whatever is this angle, these 2 angles are basically complementary angles. So if I consider one angle as theta, then the other angle can be considered as 90 minus theta. So these 2 are complementary angles, right? It is given that the distance of the 2 points, so this particular distance, this horizontal distance is 4 meters and this horizontal distance is 9 meters, that is given to me. So this distance is 4 meters and this particular distance is 9 meters. Now I have to show that the height of the tower is 6 meters. So I have to show that h equals 6. So again, let me pause for a few seconds while you take a look at the question and the diagram, and then we shall move ahead and solve it. Okay, so let us now think about the solution. First of all, I can pick the triangle. I do not know the angles over here, but I can definitely pick this triangle. So I can say in triangle TBR, tan theta is going to be the opposite side upon the adjacent side, which is h upon 4, right? And let this be my first equation. Then of course I can pick another triangle. I cannot pick the triangle ABT because it is not a right angle triangle, but I can pick the triangle ART. So I can say in triangle ART, I can say that tan of 90 minus theta is going to be h upon 9. The whole length is 9. And according to the complementary angle relations, if you remember the complementary angle relations, we know that sine of 90 minus theta is cos theta. So sine and cos are related by the complementary angle relation. Similarly, tan of 90 minus theta is equal to cot theta, and sec of 90 minus theta is equal to cosec theta. Therefore, I can say that tan of 90 minus theta is cot theta, and cot theta is going to be h by 9. This is the second equation. Now I have these 2 equations. I do not know the value of theta, so there's no point in having tan theta and cot theta because I cannot determine their values. However, one interesting thing that I can do is I know that the product of tan theta and cot theta is going to be 1 because they are the reciprocal of each other. So what I'm saying is, I know that tan theta is h upon 4. I also know that cot theta is h upon 9. So if I multiply these two equations, I will get tan theta multiplied by cot theta is equal to h upon 4 multiplied by h upon 9. Now tan into cot is 1, which is equal to h into h is h square upon 4 9s are 36. And this implies h square is equal to 36, which means h is square root of 36, which is equal to 6 meters. Therefore, the height of this particular tower is 6 meters. Some important concepts that we used in this particular problem were the complementary angle relation. I think this is one important idea that came up in this particular question. And then of course, because we didn't know the value of theta, we decided to eliminate theta by just multiplying these two equations, because we noticed that tan and cot are the reciprocal of each other. So if you multiply them, they will cancel out each other. So this is how I went about this particular question. Let me pause for a minute and then move to the next one. Moving on to the next question. Let us take a look at the following question. An aeroplane, when flying at a height of 4,000 meters. Okay, so let's quickly draw. This is the ground, and there is an aeroplane which is situated right at this particular point A. This is the aeroplane which is at a height of, so this is aeroplane 1. This is at a height of 4,000 meters. That means this particular height, this total height above the ground, is going to be 4,000 meters. So this particular height therefore is 4,000 meters. So an aeroplane, when flying at a height of 4,000 meters from the ground, passes vertically above another aeroplane. So it passes vertically above another aeroplane. That means this is the other aeroplane. The aeroplane A is vertically passing above the other aeroplane. That means A is exactly in line with the other aeroplane B. So this is aeroplane 2. At an instant when the angle of elevation of the two planes from the same point on the ground. So let's pick a point on the ground. The angle of elevation of these two aeroplanes from the same point on the ground. So P is a point on the ground. The angle of elevation of these two aeroplanes is found to be 45 degree and 60 degree. That is, this particular angle is 45 degree and this complete angle is 60 degree, because these are the angles of elevation. Now we have to find the vertical distance between these two aeroplanes, right? So we have to find this particular distance AB. This is the vertical separation of the two aeroplanes. This is the vertical separation. This is the vertical separation of the two aeroplanes. So let us see how to go about this particular question. Now I know that the complete height is 4000 meters. So if somehow I can find the length of BC, then from 4000 I can subtract BC to get the vertical separation of the two aeroplanes, right? That is how I'm going to think about this particular problem. So if I want to find the length of BC, then if I know the length of PC, it would help me, because then I have a 45-degree triangle, I can easily find it. So let me first find the length of PC. So how can I find the length of PC? For finding the length of PC, let me take the entire triangle, that is APC. So I can say in triangle APC, if I take tan 60, so 60 degree is the angle, the opposite side is 4000 meters, so I can find BC. So tan 60 is therefore going to be 4000, the opposite side, divided by the adjacent side, which is BC. Now tan 60 is root 3, so root 3 is 4000 divided by PC, which means PC is equal to 4000 divided by root 3. So this length is 4000 divided by root 3 meters. This is the horizontal length BC. Now if I want to find the length BC, what I can do is, I can now consider just the triangle PBC. I now know the base of that particular triangle, right? So I can take triangle PBC. So in triangle PBC, I can say tan 45 degrees. Tan 45 degree is going to be BC upon PC, which is 4000 divided by root 3. And therefore tan 45 is 1, which means BC is going to be 4000 divided by root 3 multiplied by tan 45, which is 1. Therefore the length of BC is 4000 divided by root 3. And therefore if I want to find the vertical separation between the aeroplanes, now what I can do is, I know that the complete length is 4000, of which BC is 4000 upon root 3. So the vertical separation is going to be 4000 minus 4000 upon root 3. Of course now I can multiply and divide by root 3. So therefore this becomes 4000 minus 4000 root 3 divided by 3, and that is equal to 4000 minus 4000 into 1.732 divided by 3, and therefore this becomes 4000 minus, now 4000 into 1.732 becomes 6928 divided by 3, and that becomes 4000 minus 2309.33 meters. So now I can evaluate this. This is going to be 1690.66 meters. Therefore the vertical separation between the two aeroplanes is 1690.66 meters. So this is how I draw this particular diagram from the given word problem, and take a look at the solution also, and then we will move on to the next one. Moving on to the next question. The horizontal distance between two towers is 140 meters. The angle of elevation of the top of the first tower when seen from the top of the second tower is 30 degrees. So something is very important here. The angle of elevation of the top of the first tower when seen from the top of the second tower. So imagine that you are standing on the top of the second tower. If you stand on the top of the second tower to see the top of the first tower, you are experiencing an angle of elevation of 30 degrees. Again, let me repeat. When you stand on the top of the second tower, so assume that this is the second tower and this is the ground. When you stand on the top of the second tower, that is at this point, at the point A, to view the top of the first tower, you experience an angle of elevation of 30 degrees. So imagine that you are standing at A. So this is your normal line of sight. Now to view the top of the first tower, you experience an angle of elevation of 30 degrees. That is, you are going to look upwards and this angle is 30 degrees now. This is the perpendicular, which means that the first tower is taller than the second tower. This is the top of the first tower and this is the bottom of the first tower. So this is the first tower and this is the second tower, because it's given that when you stand on the top of the second tower, the angle of elevation of the top of the first tower is 30 degrees. That is why this is the second tower. It's given that the height of this tower, second tower, is 60 meters. And now we have to find the height of the first tower. Now it's given that the horizontal distance between these two towers. So the horizontal distance between these two towers is 140 meters. The height of the second tower is 60 meters. When you stand on the top of this second tower, the angle of elevation of the top of the first tower is 30 degrees. We want to find the height of the first tower. So try to correlate the word problem with the given diagram and in a few seconds we will solve this question. So let us now solve this particular problem. Because the length BR is 140 meters, I can say that the length AD is also 140 meters. And because the length of AB is 60 meters, the length of RD is also 60 meters. Now in this particular triangle, there is one triangle that I can pick here. In this particular triangle, because I know the length of AD, I can find the length of DT using trigonometry. So I can say in triangle ADT, tan 30 degree is the opposite side, that is TD, divided by the adjacent side, which is 140. And therefore 1 by root 3 is equal to TD upon 140. Therefore, I can say that TD is equal to 140 divided by root 3. Now, of course, I can rationalize the denominator. I can multiply both the numerator and denominator by root 3. So this becomes 140 into root 3. This becomes 140 into root 3 divided by 3. And that's 140 multiplied by 1.732 divided by 3, right? And therefore that answer is 80.83 meters. Therefore this length is 80.83 meters, and therefore the total height of the first tower is going to be 80.83 plus 60, which is going to be 140.83 meters. This is the height of the first tower. So this is how we solve this particular problem. I will now pause for a minute and we end our today's session over here. I hope you understood all the questions that we dealt in today's session. Ending today's session here.